In the Hfnn classifier we studied in the previous video, instances were weighted based on their bad Hfnn scores. However, they used their own class labels to vote for the label of the instance to be classified. Next, we are going to study a Hfnn classifier in case of which instances do not use their own class labels, but they vote by the labels of those instances for which they appear as nearest neighbors. This may sound a little bit confusing, so let us consider an example in order to see how this works. We will use our running example and we want to classify this yellow triangle that is instance 11. Again, we will use two of its nearest neighbors in order to classify this instance. The two nearest neighbors of this yellow triangle are instance 6 and instance 9. Instance 6 belongs to the class of circles, whereas instance 9 belongs to the class of rectangles. However, as we said, we will actually not consider the class labels of the instances themselves, so instance number 6 will actually not vote for the class of circles, and instance number 9 will actually also not clearly vote for the class of rectangles. So what happens is the following. Let us consider instance number 6 first. We count how many times this instance number 6 appears as the nearest neighbor of rectangles and circles. As you can see, this instance number 6 appears twice as nearest neighbor of rectangles, whereas this instance number 6 never appears as nearest neighbor of a circle. Therefore, we argue that having instance 6 as one of the nearest neighbors is an indication of being a rectangle. So, this instance number 6 will actually vote for the class of rectangles. What is the situation in case of instance number 9? Instance number 9 appears once as the nearest neighbor of a rectangle and once as the nearest neighbor of a circle. Therefore, having instance number 9 as one of the nearest neighbors can be seen as an indication for either being a circle or being a rectangle. And in particular, in this example, instance number 9 will vote both for the class of circles and for the class of rectangles. Now, let us see how this works numerically. We use C1 to denote the class of circles, and we use C2 to denote the class of rectangles. We will calculate the quantity UC1 for instance 6, and this quantity can be seen as an estimated probability that instance 6 appears as the nearest neighbor of a circle. In this example, instance 6 appears twice as nearest neighbor of some other instances. However, it never appears as the nearest neighbor of a circle. Therefore, this UC1 x6 will be equal to 0 divided by 2, that is, it will be equal to 0. Similarly, we estimate the probability that instance 6 appears as the nearest neighbor of an instance from the class of rectangles. As instance number 6 appears twice as the nearest neighbor of some other rectangles, and it appears in total twice as the nearest neighbor of some other instances, therefore this UC2x6 will be equal to 2 divided by 2, which is equal to 1. We can calculate UC1 and UC2 for instance number 9 as well. In particular, for instance 9, both UC1 and UC2 will be equal to 0.5 because instance number 9 appears twice as nearest neighbor of some other instances. However, once it appears as the nearest neighbor of circles and once it appears as the nearest neighbor of rectangles. We use these quantities in order to vote for the both classes. In particular, we will have in total a vote of 0 plus 0.5 for the class of circles, and we will have a vote of 1 plus 0.5 for the class of rectangles. Of course, if we want to estimate the probability of one of the classes, then the sum of the votes for that particular class should be divided by the sum of all the votes. This is what you can see in this slide. According to these calculations, we estimated the probability of the first class, that is the probability of circles, as 0.25 for this instance 11, whereas the probability of the event that instance 11 belongs to the class of rectangles is estimated as 0.75 in this example. So, instance 11 will be classified as a rectangle because the class of rectangles for this instance has a higher probability than the other class. The next slide shows the general formula that describes how this classifier works.